when we buy our shoes and our clothing, we like to make sure that they fit. And especially if we're going to a major event like a wedding, then we really want to make sure they fit. We might go to a tailor and spend a lot of money to make sure that happens. So this is possible to do in clothing, but it turns out for other engineering components, especially those that are metallic or made out of hard ceramics, getting exactly the shape that you want in the component can be very challenging and also very expensive. So I work with a technology called 3D printing, and part of the promise of 3D printing is that with these other difficult to manufacture materials, we can now make it into exactly the same geometry you want. It is like painting, but using a laser as a paintbrush to paint a three-dimensional picture. And when you finish, you get a part made out of the material that you want, exactly the same geometry, exactly the same shape, exactly the same intricacies that you might imagine. It's like magic. Unfortunately, there's no such thing as magic in research, and we always have trade-offs. So one of the big trade-offs when we do this is that when the material is printed, the property of the material changes. A piece of steel that goes in no longer behaves exactly like the same piece of steel that has came out of the printer. So what exactly happens during the printing process that modifies the properties of the material, modifies how they behave, and modifies what we want to use them for? These are the questions that we're trying to answer in our lab. And if we are able to answer these questions by studying the internal structures of the material and how it's being modified by processing, then maybe we can intentionally change the properties of materials. Maybe we can make a part where, although everything's made out of the same material exactly, different locations within that part may have different properties to better reflect the need and operational principles of this particular component.